I did a terrible job a few months ago at the end of problem 355, clearly showing how to get the heat transfer for each of the four processes once we had found the work out. So basically, I had left out a much needed slide regarding the statement of the first law for each of the four processes. So let me try to clean that up a little bit. And I'm trying to, let's see, there we go. I forgot about share screen, so you have to forgive me for getting started again. So we'll go back to slide 19, where I summarized the work out. So we've already finished getting the work out for each of those four processes. We observed that for the two of the processes, 2 to 3 and 4 to 1, they were simply visually zero. Those were easy. The other two, a little harder. But certainly recall that by looking at the pressure specific volume diagram, you've got little w out equals the integral of PD little v. And so therefore the workout, capital workout, is the integral of PD capital V. And that's simply, remembering the definition of specific volume, it's simply going to be M times the integral of PD little v. And of course, you see that we were able to determine all those numerical values with all the intricacies in the English units. So here's a little cleanup. Now, this is going to be a slide that I did not include, and I'm going to try to clean up here. And how would we find the heat transfer for all four processes? Well, that's where, now that we've gotten the work, we're going to apply the first law for a closed system for each of the processes. Qn minus the work out, yep, got it, for each process, equals delta capital U. And so we just found all of those values. And so we'll just solve straight out for Qn, which is going to be delta U plus capital W out. Okay, and so now to try to make it a little cleaner, here you see numerically the heat transfer added for each of the processes in units of BTUs, because we've got our units all straightened out. Okay, and so that's a slide I think that I didn't show in my initial video. And this one just catches us right back up to where we were, where we're going to summarize our hard work for all processes, the work out, the heat added, and then sort of, and also the change in internal energy. And the neat thing to observe that I think maybe I didn't point out, we're analyzing a cycle for this problem 355. So if we add up all of the delta U's to check our work, we should definitely get the sum of all the delta U's is zero, because we're starting and ending at the same state, state one. So this is a great check on our work. The thermal efficiency you're going to get much better at in chapter 5. So we'll sort of leave it there. And again, to take the same opportunity to repeat some of the keys, start with a sketch. In this one, we were given TV diagram. We had to draw on our own a pressure volume diagram to visualize the work. We planned what we were going to do. We used fundamental equations. We didn't say, oh, I've got to find some set of formulas that delivers me to the promised land. Blindly using formulas is a loser. So by working with the fundamentals on your homework problems, that helps you to prepare well for quizzes and tests. Let's see another detail. We checked and wrote down units as we went along. We didn't just write down numbers. And in the final expression of the results, we expressed our numerical results along with units. And so that is that's it. Let's see. I'm trying to refresh my memory on where I go from here. Let's see. I've stopped sharing, and I believe that is it. Now I've got to remember how to stop recording.